Hello. Now we are going to look at the names and the rules connected to lines and angles. And we're going to start off by looking at the names for the different sizes of angles and then some rules connected to them. Before we begin, the names for angles are sometimes given by Greek letters. So alpha is 3/4 of an infinity sign, beta is like a capital B with a tail, gamma looks like that, and theta is a 0 with a squiggly line in the middle of it. And they can be used as names for angles, or we could just use capital letters or XYZ. We can see the angles labeled in lots of different ways, but sometimes it's using these Greek letters. Now, if we have an angle that is between 0 and 90 degrees, we call it acute. So the angle from A to B to C, the angle from A to B to C is the angle alpha, which is an acute angle because it is between 0 and 90 degrees. So to name an angle using 3 points, we say we start here and we walk to the angle and then we walk out the other arm of the angle. We could also call this angle CBA. That would be the same thing. So we could call it C to B to A. So we start at a point, walk to the angle we're talking about, and then walk out the other arm. And that's how we name our angles using 3 letters. Often we will also call them alpha, beta, gamma. We'll put a label in the angle itself. And occasionally you will see the angle called by the letter of the point that is actually in the corner. This is not as common and can lead to confusion. These two would be by far the most common. So we have our acute angle and we've looked at how we label our angles. DEF or FED is a right angle and it has a little capital L looking symbol in it, or it can also have the box going that way. That would also mean a right angle. We can have angles that are greater than 90 degrees, so greater than a right angle, but less than 180 degrees, and they are called obtuse angles. So GHI or IHG would be our obtuse angle beta. A straight line has 180 degrees and is sometimes called a straight angle. An angle between 180 and 360 is called a reflex angle, which I've labeled here as gamma. And you would have to explicitly label a reflex angle because by default we tend to mean the smaller angle. So if we just started talking about the angle between these lines, by default we would tend to mean this angle in here. So if we don't specify otherwise, it's the small angle between lines that we tend to mean. So particularly if we're talking about reflex angles, we have to be specific in our labeling. Finally, we have that if we add up all the angles going all the way around one full rotation, we know that we've gone through a full circle, so we've gone through 360 degrees. So rotating through a straight line is 180, and then double that would go all the way around to back where we started would be 360. Some rules connected to this. We have vertically opposite angles are equal. So we have our two straight lines crossing each other here, and the angles vertically opposite each other, so directly opposite each other, are equal. So the angle labeled X here is equal to the angle labeled Y. They must be equal. They must be the same. You can construct triangles to prove that this must be true, but they are vertically opposite, so they're equal. So X and Y are equal, and for the same reason, W and Z are equal. They are opposite each other, so they are equal to each other. Alternate angles means that if we have two parallel lines, so our arrows here mean parallel, as our blue writing says, and our symbol for parallel is our two parallel lines, vertical parallel lines. So we have our two parallel lines going here with our arrows, and we have a line crossing the parallel lines. And the angle in between the parallel line here and the angle between the parallel line here must be the same. They alternate the side of the line that they are on. So alpha is on one side of the line, beta is on the other side of the line when we are crossing our parallel lines. So they alternate the side of the line that they're on, and they are equal to each other. This is sometimes called the Z rule, and is a very common one that we need to watch out for. A connected one is called corresponding angles. So angles that are in the corresponding position. So again, we have two parallel lines, or however many parallel lines we like. We have a line crossing those parallel lines. And the angles that are in the corresponding position, or the equivalent position in the next crossing, must be equal to each other. So that's corresponding angles. And then as a consequence of some of our previous rules, we have the interior angles, so the angles on the same side of the line where we're crossing parallel lines on the inside here must add up to 180 degrees. You can see this from our alternate angle is one of the ways that you can see this. We have angle A here. The alternate angle would be over here. So that would be the angle A as well. And we know that A and B go through 180 degrees. They are angles around a straight line. So that means that A plus B must add up to 180. So that's a derivation of where that rule is coming from. Now, let's put these rules and these naming schemes into practice. So we want to find the angle M and the angle N. And the only information we're given is that the obtuse angle is 130 degrees. Well, the obtuse angle, I go back to my definitions and I say, well, the obtuse angle is between 90 and 180. And I have my straight line here, and 90 would be going straight up and down here because my line AC is horizontal. So perpendicular to that at 90 degrees to that would be going straight up and down. So I can see that N is bigger than 90 degrees and M is less than 90 degrees. So M is acute and N is going to be obtuse. So I can immediately say that angle N must be 130 degrees because I was told the obtuse angle I'm talking about here is 130. Now, how would I find the angle M? Well, the angle M plus the angle N goes through a straight line. So that means angle M plus angle N must add up to 180. And I know that angle N is 130. So I can rearrange my equation to get that M is 50 degrees. Now, just as a naming point, the angle M could also be called ABD or DBA. So let's write that down. And the way that we are getting that is we start at one of our points, we walk to the corner we're talking about, walk into the angle we're talking about, and then walk back out along the opposite arm. And that's how we get the names for our angles. So if we want to find alpha, beta, and gamma, and we know that the reflex angle is 240 degrees, well, I know that the reflex angle is between 180 and 360. So I can see alpha is going to be my reflex angle. So I immediately can write down that it's 240 degrees. I know that beta has the right angle symbol in its angle. So I know immediately that beta is going to be 90 degrees. So all that remains to me is to find gamma. Well, I know that alpha plus beta plus gamma must add up to 360 degrees. If I add up all of the angles going around a circle, I must get 360 degrees. When I work that down, I get that gamma is 30 degrees. Now I have my two straight lines crossing each other here, and I have 120, 4x, 2x, and 3a. So how would I find the values of x and a? Well, I know if I added all of these up together, I'd get 360, but that would give me an equation that had both x and a in it. So I might do that if I couldn't see anything else to do, but there are other things that I can do, because I know that 120 is vertically across from 4x. So that means 4x must be equal to 120 because they are vertically opposite. And anytime I use a rule like that, particularly any of our 4 rules here, it is important to write down why it is that what you're doing works, because we need to be quite fluent with these tools. We need to be quite fluent with these rules. And it's by writing them down, by physically writing them, that we remind ourselves of why it is we're doing what we're doing works. So if we write down Anytime that we use the fact that vertically opposite angles are equal, we write down vertically opposite next to what we're doing. That will get it stuck in our long-term memory, and then when we need that tool in the long run, we'll be able to access it. If we just write down 4x is equal to 120, there's a lot less groundwork left in our memory to latch onto. So always write down any of the rules that you use in geometry, because we need them. We need to be able to use them quite creatively. So you need to reinforce them every chance you get. Now, we know now that x must be 30 degrees, and we know that 3a and 2x are vertically opposite. So 3a is equal to 2x because they are vertically opposite. So we can solve for a. So we have 3a is equal to 2 on 30 degrees. So 3a is equal to 60 degrees. So we divide both sides by 3. So therefore, a is equal to 20 degrees. Now, that is not the only way we could approach this question. You could also say, well, I have a straight line going on here. So 3a plus 120 must add up to 180 degrees. And when we write that out, we find that we get the same value for a because they are logically equivalent ways of writing them. But if we can spot these things, again, in geometry, we need to be able to see all of the tools available to us very readily. So if we can see more than one way to do the question, it's a good idea to write it down and simply check that you get the same answer, and always write down why what you're doing works, and you're reinforcing your understanding by doing so. So we have a bunch of angles to find here, and there's more than one way to find most of them. So we have the two parallel lines from our arrows, and we have a line crossing our parallel lines. So we have 30 degrees up here, and we have A. Well, A and 30 degrees are vertically opposite. Then we can say, well, A and B are corresponding, so they must be equal too. B and C must add up to 180 degrees because they're rotating around a straight line. So we can say B plus C adds up to 180. And angle D, well, angle D, we have several options for everything we've done, but here we can immediately see we have A is alternate to D, so they must be equal because they're alternate. Or you could say B is equal to D because they are vertically opposite. You could also say that C plus D must add up to 180 degrees as well, because they're rotating around a straight line, or they are rotation around half of the side of a straight line. So we have everything up to D. So how would we get E? Well, we could say that E and C are corresponding angles. We could say that 30 plus E must add up to 180, or we could say that the interior angles, E and D, must add up to 180. So we have several options there for finding E. So there are many ways that we can approach finding angles that are equal to each other. And in different circumstances, as the questions get more advanced and more complicated, we'll have to get very good at spotting what tools apply where. So the more we look for alternate ways of finding things, for different ways of approaching the same question, and the more we label why what we are doing works, why this is true, the better prepared we are for when these questions get more complicated. And that's what we need for now.